So this is basically the solar panel that we'll be using to send the signal to close or open the chicken coop door. So prior to installing it outside, we need to run couple tests here just to make sure that we are seeing a signal in here. Now this is a solar panel intended for a 12-volt battery, so it'll charge up to about 20 volts. So we have a resistor array here. There's 4 resistors hooked up in parallel. They're 3K, 3 kilo ohm, so altogether about 750 ohm. And this big one here is about 220. So what we want to do is we want to get the signal down to about 5 volts. So let's just go ahead and measure it here. Alright, so we need to measure this voltage to make sure it's not above 5 volts. There's a little bit of sun outside now, but it is behind a window, so more than likely it won't be a very high voltage. So we have to measure at this ground point and the point that's going to go to the input. So 2.4 volts, which is pretty good. Obviously we don't need it at right exactly 5, because if it goes above that, then we got some problems. So we're going to go ahead and hook up this little resistor array into the Arduino right here, and then we'll write some software for it. So let's go ahead and do that. Alright, here's our resistor array and the Arduino board. A little tricky to see, but it's there. So we want to hook this side up to ground, and then we're going to hook this part up to the input, the A0 input. Just kind of wrap that wire around. Yeah, it's not a professional job, but we're just using this as temporary testing. This end is going to hook up to the solar panel, and this end will hook up to the solar panel. So if you see, just like that. And then we'll hook that up to there. So that's pretty much all the hardware that we need to do. It's pretty straightforward. So we got the 0 to 5 volt signal coming into A0, and then the power from the solar panel is coming in here. So let's go ahead and look at the software that we need to derive. Alright, so one of the first things you'll want to do, if you don't already have the Arduino IDE, basically what interacts with the Arduino board. Very simple tool for very simple development environment. Now, a bunch of examples of programs written up here. Analog in, out, serial. This is what we're going to be using because we have an analog signal coming in, and we want to have it go out with a serial. So this stuff is all written. As you can see here, goes an analog pin A0, one that we hooked up to. Value read from pod, initializes the values, setups the serial for the baud rate, it's like speed, I guess. And then this is where it intakes the sensor value, and it goes to an analog to digital converter, which records it in 10 bits and outputs it in 8 bits. Hence the mapping there. And then it'll write the value to the serial screen here. So let's just go ahead and burn this onto the computer chip, and then we'll see what happens. Since we basically didn't change anything, it should compile. So let's go ahead and open up the serial monitor and see if it has anything. So as you can see, the sensor is outputting about 120, so about half of 255. And it's outputting at a lot higher rate than we need. So let's just go ahead and exit out of that and Maybe we can change this to a higher value, just so that it doesn't get completely out of control. Just change it to 500. That's the delay value. It's basically the sampling rate. Yeah, I guess I should say that, the sample rate. Let's go ahead and upload that, see what happens. Alright, done uploading. Let's open up the serial monitor. See, now it's outputting at a more reasonable rate. Now you may look at that and think that those are just random numbers that don't really mean anything. So if we unplug the solar panel, it should go to, it'll be a floating value. Basically goes to nothing. Now we plug it back in. Just like that. Now it goes back. What we want to do is it'd be nice to data log this value so that we know approximately when this output drops to 0, the sun is no longer out. So let's go ahead and see what other kind of tools we have available. This is a serial monitor. Now, I haven't actually used this before, so let's just go ahead and, well, apparently COM4 is the one we're reading. So these values look very similar to the ones we just saw. So that should lead you to believe that it's probably the same sensor. Let me just double check. I'll unplug the solar. All right. So now what we want to do is we want to data log this. Now let's see here. I think there's something. Oh, send text file. Capture to text file. Let's go ahead and capture this to text file. Let's see. Cool term capture solar stuff. All right, just save that. Now we let it run for a little bit. And so I'll just go ahead and stop it now. I already forgot where it was captured to, so we're gonna have to, all right, cool term win. All right, so let's go ahead and access this folder, cool term win, cool term capture solar stuff. And there we have it. So could probably, about that, could probably put this into some Excel sheet. Let's see here. All right, well, yeah, I guess I don't really remember how to put it in there. But somewhere in here, you can import from a text file. Maybe I should look it up here. Oh, let's try this one here. Bunch of words. Oh, apparently it claims you can just open up a text file, so I guess we can give that a shot here. Cool term. No, it should have been in this file here, so change that to all files. Now let's see what it does. Alright, let's know what any of those numbers mean, so or don't know what those words mean. Delimiter. All right. So it looks like we got this. Yeah, I got it in both columns. All right, so I guess that's pretty much how you data log to an Excel file. Would be nice to have a time on here. So maybe we can add some real-time clock into the Arduino, or probably a way to get it on the software too. We'll go ahead and for part 2 we'll figure that out and be right back.